Hello everyone, my name is IKHWAN ASUN, and today I'm gonna talk about the related rates. So, application of related rate. Related rate are so important because there are so many real-world application of it, like snowball melting, a ladder falling, a balloon being blown up, and two people or animal moving away from each other at a right angle. So what is related rate? Related rate involving finding rate at which a quantity changes by creating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to the time. And last, why? We use related rate because it come in handy when we have two related quantities and one of the rate of change is much harder to find than the other one. The related rate in math is a process to finding the derivative rate of change of a function. It can be carried out by purely algebraic manipulation using three basic derivatives, four rule of operation, and a knowledge.
Hi, my name is Adilah Mustafa. So this is a little introduction about me. Okay. Alright. My name is Adilah Mustafa, and my ID number is 2020464424. My group name is A4AS 1202C. Program code MAT183 and course code AS120 and course group A4AS 120310. 10. Okay, hi. I'm going to present about the problem statement at question C. So, an airplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When delta equal to pi over 3, how fast does the camera have to rotate in order to keep the plane in a view? So, if you realize it is the angle of elevation, so we can do this triangle, okay? So, it's make you become more easier to see it, okay? Alright, so when this question say the altitude of 5 km is approaching, okay, wait first, of 5 km. So we know that the distance between the planes and the ground is 5 km. So it is constant. So it means it does not change. Okay, alright. So we as we don't know the distance, so we put it as x first. So why, and now we want to know why this question give this point. So we can see 450 km per hour, so it means it is dx. Okay, we put it as, right, so we put so it can be dx over dt. So we need to know it is whether it is a decrease or increase. How we want to know it? By see the sentence. Okay, it is if approaching, if you guys realize and remember, approaching a camera mounted, so it's become more near to camera, so it is a decrease. So don't forget to put negative it is if it decrease. Alright, so this question say when data over pi equal to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? So this question 1, d delta over dt. So yeah, it will be continued by my member. my member group. So that's all for me. Thank you.
Assalamualaikum, my name is Muhammad FAIZ bin ARIS from group 4, 2021 131493 AS120 MAT183 2C. Okay, so we're gonna go with problem solution. So from the question, we know that the speed, the rate of change of distance is 450 kilometers per hour. The height, the altitude of the airplane is 5 kilometers, and the airplane is approaching a camera, meaning it's moving in the negative direction. And then we have theta, which is 5 over 3 radian, and the question wants us to get the rate of change of theta. Okay, so related rates, we use chain rule. Here we have the d theta over dt is equal to d theta over delta d times delta d over dt, because delta d over dt is the one that the question gives, and d theta over dt is the one that the question wants. So we can rewrite like this: d theta over dt is equal to negative 150 times d theta over dt, because it negative because it's moving in the negative direction, it's approaching the camera. And then in order to get d theta of dt, we must first find theta in terms of d. So we can do like triangle, like right angle triangle like this. So we have camera, airplane, and the hypotenuse is the line of sight of the camera. Adjacent side is the horizontal distance, and the opposite side is the vertical distance, 5 kilometers. And here we have theta, so we can use this to get this, and then we can write as the trigonometric ratio cotangent theta is equal to a over 5, and the theta is arc cotangent of a over 5, and then we differentiate theta in terms of a, we get negative 5 over a squared plus 25, and then we can put this in the chain rule. So we get d theta of dt is equal to negative 150 times negative 5 over a squared plus 25. And then here the question gives us theta, and then we have to use theta to get a. So we can rewrite this as a is equal to 5 cotangent theta. And then here we have when theta is pi over 3 radian, a is 5 cotangent pi over 3, which is 1 over square root of 3. And then a is equal to 5 over square root of 3. And then we can put this in this. So we get this 135 over 2, or 67.5 radian per hour. We can, the unit is radian per hour because our theta is in radian, and our t is in hour. So this is the final answer. Thank you.
Hi, I'm here again. I'm going to present about conclusion and overall questions. Okay, so this is conclusion that have been made by my teams and also me. So first conclusion, we need to use and understand the different tactics to solve this question. And second, we also have to determine either the expertity is decreased or increased. Third, we need to find the value of x. And the last thing, the important thing is, before we solve to get the final answer, we need to simplify to make the calculation become more easier. Okay, that's all for me and also my team. I hope it will help you little or much. But thank you for watching and bye.